And thank you so much for watching this video. My name is Dr. Hassan Azza, and the today topic of discussion is the panel data analysis. We called a data as a panel data which have multiple cross section as well as multiple years. So a panel data, which is also known as a longitudinal or cross sectional data, is a data set in which the behavior of the entities are observed across different time periods. These entities could be the states, the companies, the individuals, the countries, etc. So as we see that the panel data look like as we have this as a cross section which is as a country. We have three countries in this data and we have multiple years for each country from 2000 to 2002. So there are multiple countries as well as the multiple years, and we are collecting data against a dependent variable and a different independent variables. We called this data as a panel data set. So this arrangement is particularly important because this arrangement uh, is mostly accepted into a data. So we first in X on our Excel we need to arrange this data. Like we have a first variable should be the cross-sectional variable, that is a country, that may be the company. Other variable should be the time series variable, and then we should have our DVs and IVs. It's better that we arrange this data like this. So while performing the panel data, usually we perform panel data with the fixed effect model as well as the random effect model. These both models have their own assumptions and they have on their benefits. The fixed effect model, we can perform the fixed effect model because we are more interested in analyzing the impact of the variables that vary over time. Fixed effect explore the relationship between predictors and the outcome variables within an entity, country, person, companies. Each entity has its own individual characteristics that may or may not influence the predictor variables. For example, being a male or a female could influence the opinions towards a certain issue, or the political system of a particular country could be some effect on trade or a GDP, and the business practices of a country may influence its stock prices. When using the fixed effect model, we assume that something within the entity, within the individual, within the cross section may impact or bias the predictors or outcome variables. So we need to control that specific characteristics of that individuals. So there is a rationale behind this assumption that there is a correlation between entity error terms and the predictor variables. So if we remove the effect of these time invariant characteristics, so we can assess the net effect of the predictors on the outcome variables. Another important assumption of the FE model is that those time invariant characteristics are unique to the individual and should not correlated with the other individual characteristics. Each entity is different, therefore, the entity error term and the constant should not be correlated with each other. If the error terms are correlated, then FE is not a suitable model. Since inference may not be correct and you need to model that relationship specifically by using the random model or a common model, this is the main rationale for the Hausman test as well. The Hausman test also exactly discuss the same thing, that if there correlation between the error term and the constant and vice versa. So for the fixed effect model, we use this equation y is equal to beta xt and this alpha plus error term. And this alpha basically is the name unknown intercept for each entity that we actually are going to control in this fixed effect. Y is the outcome variable and the x is the a independent variable. Beta is the coefficient of that IV and u is the error term. So the key insight is that if the unobserved variable does not change over time, then any changes in the dependent variable must be due to the influence of the other than the fixed characteristics of that dependent variable. So this is according to the Stoke and Watson 2003. In case of the time series cross-sectional data, the interpretation of the beta coefficients would be for a given country as x varies across time by 1 unit, y increases or decreases by beta units. This is for specifically discussion of this these authors. Phase effect will not work well with data for which within the cluster variation is minimal or for slow changing variable over time. So the for this thing when within cluster variations are minimal and the slow changes over variable, usually we go for the common effect model instead of fixed effect model. So these are some theoretical discussion of the fixed effect model. So overall, fixed effect model is a model in which basically we are going to control the specific the individual's characteristics or the entity characteristics or the country specific own characteristics so that and IV could properly predict your DV. This is the output that we will see on our fixed effect model. So first we go to the data on SPSS on your Stata. So this is the data that we have. We can see that we have a country variable, cross-sectional variable, right? A country is a cross-sectional variable here, A, B, C, D. Then we have a year from 1990 to 1999. We have a data here. Then we have Y, that's a Y binary variable if you want to from logistic regression that we will see in the further lectures. Then we have three filter for the simplicity. So in this data we have a cross-sectional data and we have time series data, a time series variable, cross-sectional variable, and then we have dependent and these three independent variables. But when we see that when we see the usually the in cross-sectional data is in alphabetic way. So when you put your paste your data into the strata, these cross-section, these alphabetic values will appear as a red sign. That means that strata is unable to read this variable, this ABC variable. So first we need to encode these values so that the strata could understand this thing. So for that purpose we need to run this code, that is the encode country, the same variable that has alphabetic values with the label, and then we need to generate and we will give another name. But as you know, you see that here it is in a blue form. It means that they are already readable in this file, so we will not need to run this code. In the second step, we need to set our data set into the into data. So Stata, when we paste the data into the Stata is not unable to discuss that either this data is a time series data, panel data, or a cross-sectional data. We need to give some command so that the Stata should know that which type of data is this. So for this purpose, we need to run a code, the xt, x for cross-section, t for time period. So xt set, you need to give some first your cross-sectional variable and then the time series variable so that they will into a panel data. So as I run this code, so we can see here the output that this Stata now understand that this data is a panel data after putting this command. So in the third step, the first step would be that we need to change the alphabetic variable, cross-sectional variable, right? Alphabetic cross-sectional variable into the Stata readable variable, right? So in the third step, we need to just a regression in with the fixed effect. So in first step, in to run a panel data, we first need to run the fixed effect model, right? To run the fixed effect model, we need to run a code string, that is then the dependent variable and then independent variable comma fixed effect. We just need to run it and we will get these results, right? So these are results of the fixed effect model. First, we will not see these results. These results will be discussed in future when we actually know that this data will have a fixed effect model or a random effect model, or we need to simply run a simple regression on this data. So in the step 4, what we need to do, we need to save with the command estimate store, right? So we just click and we store with the name as fixed, right? So we save this command. Then in the second step, in the fifth step, we need to run these same equation that we have run here, but now we need to run it with the random effect that we need to change FE to RE, right? Just run this command and we will see a fixed effect results. After these results, we need to also store output of these results into the random. So we have two extra variables, that is the fixed effect and the random effect that we have run. So with this we need to run Hausman test. So I first need to perform Hausman test and we just see the results that Hausman is insignificant. When the Hausman is significant, what does it mean? You need to see HR. The difference in the coefficients is not systematic. So it means that we have accepted uh, null hypothesis, that is the difference in coefficients is not systematic. It means that we should not perform the fixed effect model. When the results, when the difference in coefficients are systematic, that means that data is following the fixed effect. But here we see that the null hypothesis has been accepted due to the Hausman test is becomes insignificant. So it means that we should not go with a fixed form model, but there is a possibility that we need to run the the our random effect model. So it means that we need to run the random effect model. But when we have a random effect model, sorry, we need to main variable x1 x2. So when we run the random effect command, so these are the random results, but we need to, in the step 8, we need to discuss if Hausman test recommends that we need to run the random effect, still we need to test either effect model or we need to run a simple OL, right? So there is a test that is called Rouge-Pagan LM test. We need to run this test and we need to see either we will go with the OLS, simple OLS, or we need to interpret the results of the random effect. So for this thing, first we need to run this command that, and we need to see the results of this, right? Yes. So if this if this uh, this Bruce Pagan test, if the probability chi bar square is significant, that is the p is less than 0.05, it means that we need to report the random effect model. And if this value comes as insignificant, then it means that we should not go with the random effect, but we need to run simple OLS. So it means here we can clearly see that as this value is significant, then so we need to run a random effect model. So we will run the random effect model, right? This is the random effect model. So we have confirmed this. But if the fixed model would come from the Hausman test, although this is not the case that we have seen here, but if let's assume that the fixed effect comes as a better choice model in our equation, then we need to confirm that either we need to perform effect or either we need to move OLS. So for this we have another test that is called XT. So we will perform this test and we will see if the probability is significant. It means that we need to perform OLS. So as we already know that we cannot perform fixed effect model on this data, so he is recommended to perform OLS, although we are already confirmed that we need to run the we need to run simply a random effect model. So we can test the other specific rotation as well. We can test the heteroscedasticity for the fixed fact model. We can test the different heteroscedasticity extra for the simple model as well, or we can run the serial independence test for this data. So we can see we can perform this serial independence data. First, we need to install these commands. But let's suppose if we can see, let's see, this is test is means that there is correlation or there is no issue of autocorrelation in this data, right? So we can also perform the heteroscedasticity test in this. Basically, mostly we can see from the graph as well, but we can perform through this. So these are the some that will have, and we can run these commands to see see the results of the panel data. Now, as we have discussed that we need to commands of random effect model, so we need to interpret the values of this and the results of this. Mostly, what we do, we also run a code that is the sdoc. This command convert your random effect results into the word form. So that is xt reg y x1 x2 and x3 and re, right? So we just run this command and we get results into the word form, right? So we just need now to interpret these results, and we will get our all interpretation. Thank you so much. Okay.